Unitary Theory of Mass. Okay, what we're going to be doing is we're going to tie what we've been talking about, spin theory. We're going to use spin theory to tie magnetism and gravity together. And of course that's what unitary field theory is. Unitary field theory is trying to tie our observations on Earth all together. These events we see that seem to be chaotic and totally opposed, such as attractions of a magnet when you have north and south attracting, but when you have north to north or south to south you have repel. We're going to tie that together with what we also have observed and since Newtonian periods and going back as far as Copernicus and Galileo. We're going to tie all these observations together. And to put it simply, we're going to tie them together with spin theory. Spin theory, of course, let's do this right now. Let's get a very simplistic approach, definition of what we're going to try and do. What we are doing, quite frankly, and as we should always do, is in an event to try, or in a trying to understand. We're going to take the things we do see and we're going to talk about them, and instead of discounting them or putting them to the side, what we're going to do is we're going to say, based on this, the things that we see about us right within arm's reach, we're going to put together anyway. And such things such as a spinning top, say, a falling apple, rising gas, clouds that float in the sky, and a moon that circles the earth, the earth that circles the sun. We're going to say these things are tied together, of course, through observation. So instead of seeing the things that in front of us and dismissing them, saying that they are not related, we are going to say all of them are related, and we're going to tie all these things with the most simplest first view we take of mass that we can measure. And Newton did a very good job, along with the other guy, the Polish guy, who also came up with calculus, to give us a means of measuring that motion. And because we were going to start there, measuring that motion, we're now going to take it a step further and make a statement, a very simple statement, that what we see before us, such as spin, top spinning, and we're going to extrapolate that atoms must do the same thing. And spin is just movement, and it's the very movement we measure with, and we call time and things of this nature, in motion, in rotation. So what we're going to do, just like a clockworks spin, and give us this moving hands to tell us where the sun is up in the sky. And then we take our math and we somehow fall into those numbers and forget the very things we see in front of us. But right now, this time, we're going to take a different approach. We're going to say the things we see are significant, and there's no way around them. There's no way around a spinning item. So now let's go right into the unified field theory and say, hey, we know that a spinning top will describe an orbit around any object where both objects are exchanging mass. The object that is the larger of the two and has more mass to exchange than the smaller object will, of course, have a more of an influence on the smaller object, and the smaller object will appear through observation and measurement to describe its motion, will describe a rotation, an arc around the object that puts so much force to it, okay, so much energy, and we'll call this transmigrational mass. And these are the terms we're going to start working with and go. First of all, energy and mass are one thing, so we'll get tied up and tripping over that, but mass and energy we're going to say are the same thing. I think it pretty well shows it, and Einstein did such a good job in showing E equals mc squared. So let's not falter there. Just like Copernicus said, there is no reason for certain stars not to do what other stars did. Let's stick with what these people observed. I mean, they were good observations. Let's not go far from them, because that's what we're doing. We're not trying to develop a schema of belief theory. We're trying to look into the nature of things and find out and predict. Not dream up something that's supposed to happen, but let's see what's going to... We're trying to predict these events. Okay, back to topic. And of course, with these terms of transmigratory mass, that mass moves between objects, period. And everything in the universe is mass, and it's in motion. So now we're going to try and understand how this mass traveling through the universe, whether it's emitted from a sun or you know, or coming around from some other place, it's still mass. It's like automobiles in a traffic jam. These automobiles are little go-butts or atoms or who knows, whatever you want to call them, and they are in a traffic jam. And they may come from afar or field, but when they get to this intersection, they're going to have collisions, and they're going to affect each other. So we're going to look at the universe as not a void of space, because space and mass, that's the definition of motion, is that mass has space to move in, and as it moves, it has motion, and therefore is the term space. Okay, so all of these things are coming down to one. We're gonna have to figure that one out. Oh, okay, but anyway. We're going to look at it like that, like a traffic jam, and we're going to say that although we can't see this mass energy that is moving through the universe very well, like we don't see air, we can see the effects. And what we're going to say is all of this is moving about, and it's going somewheres, and it is colliding at intersection points. We call them, you know, suns, solar systems, galaxies. But this collision of mass, of course, occurs here. And we see all kinds of stuff. So this is the fundamentals of which we're going to base our discussions on. And because we're doing this in 6 minutes to 7 minute segments, we're going to sometimes fall short of making all our points. And you can't turn the page here. We have to make another movie, but we'll do that. Okay, and what I don't cover this time, or what I flub on, I'll try and correct next time, because I do read these texts, look at them, and see where I messed up, and formulate another approach and another little discussion. Okay, thank you.